All right, so yesterday when we solved these exponential and logarithmic equations, it was just like one logarithm or one exponential expression, and today we're going to have multiple. And so we're going to have to use these properties. So the properties of exponents that I think you guys are pretty good at, that you've known these for a while, and you're getting really good at this one, that a negative exponent just means a fraction. But we're also going to need the properties of logarithms, which is the first year you've learned these. And we're going to use all of these properties in reverse. And so we'll have two logarithms separated by addition, and then we're going to use multiplication to bring them together. I feel like nobody's listening. All right, or we have two logarithms separated by subtraction, and we'll use division to bring them together. And the last property, if there's a number in the front, we can move it up to a power. All right, so whenever you're doing these equations with multiple logarithms, your first step is to bring them together using one of the properties. And when you do that, you'll have one of two forms. You'll either have log equals a number, and when it's that form, you're going to solve exactly like we did yesterday. So you're going to convert to exponential form. The other way is you'll end up with log equals a log. And when you have log equals a log, all you have to do to solve is just drop off the logs. Now, what I feel like is challenging today is the algebra you need to solve these. So you're going to have to remember a lot of things about factoring to be able to solve. And then you also need to remember those properties. Okay, and I want you to underline this. So on an important note number 1, in both of these cases, we need to check for extraneous solutions. Do you guys remember what extraneous solutions are?
Not true.
They're not true. They're false solutions. So it's whenever you do everything you're supposed to do to solve it, but when you plug it back in, it just doesn't work. And it doesn't work in this case because of the restrictions on the argument. So if you guys remember when we talked about logarithms before, that argument part has to be greater than 0. So it cannot be 0 and it cannot be negative. So the argument has to be greater than 0. So we'll have to check those as we go through. And then like a common mistake that people make is they drop off the logs too soon. And so if you have something like this, they'll just drop the logs off and then say x plus y is z, and that's not true. So to be able to drop off the logs, it's 1 log equals 1 log. All right, now there are way too many examples for me to be able to finish this in class. Maybe we could finish in class, but it would just take the whole class to do the examples. So I'm going to skip some. And so I am actually going to skip A and B. And we're going to go to C. All right, now A and B are a little less challenging than C. So don't be surprised if you go to do your assignment and it's just like a simple linear equation to solve. So that still is going to happen on your assignment. But on this one, before we can do anything with solving for x, we're going to need to bring these two logarithms together. What are we going to use to bring them together if they're separated by addition? Multiplication, good. So this will be log base 3, and then we'll multiply those two arguments together. All right, so once you get to this point, you've combined the logarithms, you have to think about which type it is or which form it is. The two forms here is either a log equals a number or a log equals a log. And this one obviously is log equals a log. And when you have log equals a log, you're going to drop off the logs. Now, as I drop off the logs, I'm going to go ahead and multiply this out. So we need to solve this quadratic equation, and the ones we're doing today are going to be able to factor them. So to be able to factor, what do I need to do first? Move over the 14. We need to equal to 0. So I'm going to subtract that 14. All right, and then we're just going to factor this real quick. Now, it is really difficult for these problems to have two solutions. I'm not saying they can't, but it's pretty rare. Because whenever you have a log equals a log, it's like a graph that looks like this, and then it's going to keep going down. And then another graph that looks basically the same. So it is really difficult for this situation to have two places where they intersect. But it's not impossible. But we always do want to check our answers. So when you check, you go back to the original problem, you take these numbers, and you plug them in for x. And if you ever get an argument that is 0 or negative, you have to kick it out. It's an extraneous solution. So if I put -4 in, are you going to get a negative argument? Yes. So then it's not a solution. What about 5? Is 5 okay? 5 is okay. All right, let's do the next one. All right, so before I can do like any solving, I need to use my properties and bring these logarithms together. What am I going to use? Division. Good. And then you have to decide which form it is, if it's log equals a number or log equals a log. And in this case, this is log equals a number, and you're going to write in exponential form. Now these kind of sneak up on you on the worksheet. So it's like a whole bunch like the first one we did, and then all of a sudden there's one like this. And if you're not paying attention, you're going to try to drop off the logs when you can. So just try to remember, you can only drop off logs when there's one on each side. So in exponential form for this logarithm, what is the base? E. So we're going to do e to the second equals x over 3. Now this is one of the cases where we're not going to just get an answer like 5 or something. Because e to the second, we can't figure that out without a calculator, and that's fine. What would you guys do to solve this for x? Yeah, multiply by 3. And so x is equal to e squared, 3e squared. Well, let's check it. So we only have one x here, and it's the whole argument. Is it possible that 3e squared would give you a negative or 0? It's not possible, so it's fine. It's a solution. All right, you guys okay? All right, we're gonna do example 5a. Now, this one is slightly tricky because the way it's written now with this 3 in the front, I actually can't bring those logarithms together because of that 3. So is there something I can do with that 3? Not multiply it. It's going to be the exponent. Very good. So you can move it up and make that 2 to the third. So now I can bring these together using division. And I know 2 to the third is just 8. All right, so I'm going to drop off the logs because I have a log on each side. All right, what would you guys do to solve? Multiply by 8. Good job. Now, I heard some people in my last class when they were working kind of talking like, how do you know when you have to factor, like get everything on one side and factor, and when you just solve it like a regular equation? Do you guys know how you know? All right, so if it has an x squared, you're going to have to factor it. If it doesn't, then we're just going to solve equations like basic equations where, in this case, I'm just going to get my x's together by subtracting 8x. And then I'm going to divide by -7. All right, and then we're going to make sure that this really is a solution. So when I take -8 and I plug it in, is it a solution? No. And that's okay, but that means there just is no solution to this equation. If we looked at the graphs of each of them, they would never cross each other. All right, now I'm going to get started on B, but I'm not going to solve the whole problem, just to save on time to do some other ones. But I wanted to do this one because of this little 2 right here, because it's kind of confusing. We actually could turn 2 into a logarithm, but is there something I could do that might make this easier to solve? Very good. So we're going to kind of switch these two. So make it log of x minus log of x minus 7 equals 2. Right, and then how would you bring those together? Division. Right, and then would I drop off the logs or would I write an exponential? Yes. All right, and then I'm going to do that and then we're going to stop. And so what is the base if there is no 10? All right, so there's the answer. It's weird. It's 700 over 99, but it's fine. We're going to just move on. Okay, and then I'm going to skip down to number 7, example 7. I feel like this might be a way that they'll ask this on the multiple choice part. So we have it, H is a logarithmic equation and K is another one. And we want to know what are the x coordinates of the points of intersection of H and K. So, and it's going to not be a calculator question. So how can we figure that out? Set them equal to each other. Very good. So I would take H and set it equal to K. And then just solve like normal. So I would bring these together using multiplication. And then because I have log equals log, I'm just going to drop off the logs, and I'm going to go ahead and distribute all that together. All right, so on this one, when you see it, and you have this x squared, then you are going to need to factor it. So to be able to factor, we're going to get everything on one side by subtracting 8x from the 5x and subtracting 2 from the 12. And then we're going to factor. And I hope this doesn't scare you too much. I have a student in calculus that yesterday, actually, he told me, he's like, I just really cannot factor one when there's a number in the front. And it made me super sad because he's crazy smart. I mean, I don't know. I don't know what happened. Maybe you guys don't practice ones like this enough in Algebra 2, and maybe we haven't practiced enough this year, but you can do this. This is not even close to the hardest thing we've done all year, and it's not even close to the hardest thing we've done in calculus, but I don't know. He's got a mental block there. But what I put here and here has to multiply to give you 2x squared. So what is that going to be? 2x in it. All right, and then if this is a minus, I know my signs are going to be different. So for me, I just go ahead and do plus minus, but know that I might have to change that in a second, but I don't have a problem with that. All right, now I can't just do the multiply to get 14 and subtract to get 3 because of the 2 that's in the front. So what I put here and here does need to multiply to get 14, but then when I do this and this, that's where I want to get the negative 3. But I honestly don't even think that far ahead. I just think about 14. So what multiplies to give you 14? 7 and 2, anything else?
1 and 14.
Yes. So those are the only two options. And then there's another thing that can help you make it an even less options. Whatever I put here with this 2 cannot have a common factor with the 2, or it's not completely factored. So I know I'm not going to do 2 and 7. I would do 7 and 2. Or if I tried 1 and 14, which doesn't really make sense to get 3, I know it couldn't be 14 and 1 because they have a common factor. So it would be 1 and 14. So let's try 7 and 2. That is the most logical thing to try, and it does end up being what works. Because close. So when I do this, I get negative 4, and that's 7x. Does that give me what I want? It gives you almost what you want. I want to get negative 3, and that gave me positive 3. So what do I need to do to fix that? Just switch the signs. Don't move anything. Just change the signs, and you got it. Now, I might have totally over-explained that, but he made me super nervous yesterday when he told me he really couldn't do that. Okay, so what does that make x be initially? 2 things. Yes. Now, it's possible that those really are our 2 answers, but it's unlikely, but we'll have to check and see. So we know that 7/2 is 3.5. Or I could even use 7/2. If I multiplied 7/2 by 2, that would be 7, and then minus 3. There's no way that's going to be a negative. Same thing here. If I take a positive and add to it, I wouldn't get a negative. So 7/2 is good. However, if I take a negative and I subtract from it, that's always going to be negative. So negative 2 gets marked out. It's an extraneous solution. Now, I know that's a lot in one day to learn, but there's more. We still have a whole nother type of equation to solve. But you got this. This one, I think you're going to be fine. I feel like we kind of practiced this recently. But these types of exponential equations are different than yesterday. So we have an exponential expression equals another exponential expression. And when you have a situation like that, you want to find common bases. So on this side, we're just going to do A, C, and E, like the first column. And so your first step is to write them with a common base. However, on A, we already have a common base, so that's good. So if this equals this, and both of your bases are 2, what has to be equal? Well, these are both 2. No, we're not using log. The exponents have to be equal. Thank you. So all we do, if the bases are the same, is just set the exponents equal to each other. Yeah, on these we're not using logarithms at all. All right, and then that just gives us a fairly simple linear equation we're going to solve by getting our x's together. And then moving the 1 over and dividing. And we are going to get a weird fraction, but that's fine. Now, the good thing about these is your exponents can be anything. Like, there's no restrictions. They can be positive, negative, zero, so we don't have to check for extraneous solutions. We're good. If you wanted to check in your calculator, like for this, you can check the answers on Google Classroom, but if you wanted to check in your calculator, you could plug that 8/3 in, and you should get the same thing on both sides. Okay, so let's go to C. C is a pretty big step up from that one, because on that first one, we had the same base. Here, we obviously don't. So what base do you think we need to change this to? 3. So it's okay. We technically could do that, but it would be really difficult with some weird fractional exponents. That's okay. So the base is either going to be one of your bases, or it's going to be smaller than both of your bases. So we wouldn't go large. We could. It would be some serious thinking. So the base here is going to be 3. So 9 is 3 to what power? The second. And then what do you think I do with this old exponent? Multiply. Good. All right, and then 27 is 3 to the third. And again, we're going to multiply by the old exponent. All right, and then once the bases are the same, we can just set the exponents equal. I am going to go ahead and multiply through. And then just solve it for x by subtracting 3x, and that is it. So I should be able to take 6, put it there. So 9 to the 12th is the same as 27 to the 8th. You'll just have to trust me, or you could check it in the calculator if you wanted. All right, and then E is a little different. I added these to Brian Passwater's notes because I saw a question like this that I would want you to do. And the only thing that makes me nervous about it is the fractions. And this would be on the non-calculator part. So all my bases are E, but do you think I can just set the exponents equal? No, not right now. What we would need to do is bring this as E to something. So if it's division, what would you do with those exponents? Subtract for division. Then, since they have the same base, I can just set the exponents equal. And this is where this gets a little difficult to do. And this is something they would expect you to do without a calculator at all. And so to solve this, I would add 1/2. So what do you have to be able to add fractions? Common denominator. You do actually. So what would the common denominator be here? 4. So how can you write 1/2 as something over 4? Nice job. 1/2 is the same as 2/4. If you need to do that the old-fashioned way, I don't know what grade it was when you learned this. You would to make the 2 be a 4, you would multiply by 2, and then you just go ahead and do that on the numerator also. Then once you have a common denominator, what do you do to add the fraction? Just add the top. So that's going to be 3/4. All right, we're not done. Now I need to take this 3/4 and I want to divide it by 7. So when we're thinking about fractions, what can you do with fractions that's the same as dividing by 7? Multiply by the reciprocal. Multiply by 1/7. Okay. Now, how do you multiply fractions? Across, straight across. So someone in my last class said across, like an X. That is not true. You multiply it straight across. So this is 3/28. And that's it. That's what X is. All right, for some people, that might have been the hardest part of the whole lesson. I hope not. I love fractions. I hate decimals. Like, someone in my last class is like, can't we just make it 0.75 and divide that by 7. I'm like, you could, but that would be so much harder. And the answer on a multiple choice test would be in fractions for sure.